Hello everyone. Today we'll look into a staircase problem question. Today we'll solve it in the practice of Geeks for Geeks portal, where we'll have to count the number of ways to reach the nth staircase. This question is most commonly called as the staircase problem. This is asked in coding interviews of Walmart, Amazon, and a few other product companies as well. Thereby, which involves dynamic programming, it is a very important question as well. Let's get going and look into the question. So there are n stairs. A person standing at the bottom wants to reach the top of the staircase. The person can climb either one stair or two stairs at a time. Count the number of ways the person can reach the top. The order does not matter. So we'll have to look into the three things which is important at this question, which they have highlighted. So there are n stairs. That could be anything which as per the input, and a person can climb either one stair or two stairs at a time. So he can climb one step at a time or two stairs, and the order does not matter. He can either climb, if there are three staircases, he can either climb 1 2 or 1 1 1 or 2 1, and so the order does not matter. So let's look into an example. So when the input is 4, that is there are 4 stairs, and the number of possibilities a person can climb that many number of stairs is 5. So how is it? You can reach 4th stair in 5 times. Way 1, climb 2 stairs at a time, climb 1 stair at a time, climb 2 stairs, then 1 stair and 1 stair. Let's look at better easily. So what we'll have to do, they've already given the question, and we'll have to return the answer in the percent model of 10 to the power 10 to the power 9 plus 7 in the complexity. So I think there are a large number of test cases which will have to satisfy. So this is the question they've given. They've already given the snippet, and we'll just have to fill the snippet for filling in the question. So let's understand the question first. So there are n stairs. Let's look at when there are 0 stairs. You are at the ground level. So the total number of ways that a person total number of ways will always be 0. But in this case, there will not be anything called n of 0. So let's get going with n is equals to 1. So the number of ways will be 1. You are in the ground step and you'll have to climb one stair. So the number of possibilities is only 1. You cannot climb 2 stairs at a time. You just have to climb one step. So the total ways is equals to 1. Let's check out when n is equals to 2. The number of ways in which a person can climb will be either directly 1 and 1 staircase at a time, or directly 2 steps at a time. So the number of possibilities is total ways through which you can climb is 2. When n is equals to 3, the number of ways is equals to, so here a person can climb one step at a time, so 1 1 1, or he can climb 2 steps and then 1 steps, or 1 step and then 2 steps, or yeah, that's the only method possible. Yeah. So when n is equals to 4, the number of ways is a person can climb the stairs can be either 2 and 2, or 2 1 1, which is 4, or either 1 2 3 and then 4, or 1 1 2, or 2 1 1. Okay, that's already there. 1, 2, 3, 4. So there are 4 possibilities, or is there anything else? Yes. Therefore, there's this other possibility of 2, 1. Okay, so you can claim there are 5 ways. There's 1 star, 1 star, and 2 stars. At a time, that's already done. 1 star, 2 star, and 1 star. Yeah, 2, 1, 1 is also there. And then claim 1 star at a time. Yeah, this is what we've missed. Yeah, for the fourth possibility. So 1, 1, 1, 1. So which totally comes around 1, 2, 3, 4, 5. Yeah. So the total ways, number of ways a person can climb is 5. So I think most of you who have worked with dynamic programming or data structures would get an idea of how we'll have to approach this question. Yeah. So if you look into it, this is something like which comes in like when n is equals to 1, there is one ways. When n is equals to 2, there are two ways. When n is equals to 3, there are three ways. When n is equals to 4, these three doesn't matter. When n is equals to 4, there are 5 ways. If these three were the only case, we could have just written n so that you'll get the answer. But always when we are working on a question, we'll have to go with a bigger number, and then here comes the complexity, and from here on it would obviously increase. So okay. So in the next thing what we'll do, yeah, this comes under the possibility of Fibonacci series. So in Fibonacci series, how does the method come? The method comes when n is equals to 0, when n is equals to 1. Let's look at the same case when n is equals to 2, when n is equals to 3, and when n is equals to 4. So what would we get the answer? When n is equal to 3, it will return 0. When n is equals to 1, it will return 1. When n is equals to 2, it will return 1. When n is equals to 3, it will return 2. When n is equals to 4, it will return the sum of the previous three numbers. So it will return yeah, so 2 plus 3 and 4. Yeah, so 4. This is something similar but not obvious, but we can use this method to arrive at your solution. So how is it when in Fibonacci series, if it is the number is 0, you'll return 0. When it is 1, we'll return 1. It is obviously the sum of the previous two numbers, right? Yeah, so here it is a different, sorry, so it is the sum of previous two numbers. So 2 plus 1 is 3. So here in the staircase problem, yeah, there are many methodologies. Here we'll follow the method 1, the most efficient method. Efficient method, which is of time complexity big O of Pn. Yeah, so let's get going. I hope you've understood the question. So let's get going with the answer. So here, since they've given that the number is huge, we'll go into with long as a return type. Why isn't typing? Yeah, so we'll go with long as a return type of, and the question is count ways is a method that we'll have to return. So count ways, yeah, and we'll have to pass in the value of m. Yeah, so before getting into the possible solution, they've here are the header cases, and here is this wait, yeah, so yeah, so there are a particular number of test cases, and that is taken as input, and while the test cases comes out to 0, we are running it, and here we are getting in the m's value, and here is the object pass. Yeah, so it's simple, and there isn't any other problem with it. So let's get going with the answer. So here firstly we'll create an array named ARR and we'll assign it the size of m plus 1, and then we'll run through a for loop for int I is equals to 0, I less than or equals to m I plus plus. So what we'll have to do in case I is less than 2, it is a lot different, similar to it, but not the way Fibonacci works. In case, since there isn't this ideology of 0 in a staircase, since you are already at the same position ground level, so in case I is less than 2, we'll have to return the array of I, which is equals to 1, the position of I and 1. Okay, else we'll get down, and here is the solution of how it has to be go about. Yeah, so the what is the Fibonacci series? It is the sum of the previous two numbers. So ARR of I minus 1 plus ARR of I minus 2. So this is all right. Yeah. Oops. Yeah. Yeah. Okay. Yeah. So we haven't taken the note of this modulo. So the modulo of this is we'll have to take this long number. So we'll have to modulo it by 10 to the power 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 7, and yes, and finally we'll have to return ARR. Yes, let's check if it runs. Yeah, so the input is n is equals to 4 and output is equals to 5. Yeah, so we're getting it. Before submitting it, let's check other. Oops. Okay, then isn't it editable? Okay, sorry, it doesn't work. Okay, let's submit it. Let's check if it works. Oh wow, we've got it, and the execution time is 0.86. Yeah, so this is the method 1 of solving the staircase problem. For finding method 2, method 3, method 4, which would be easier when compared to this, check it the next other videos. Thank you. Have a great day. Bye bye.